Hello everyone. I'm very glad that you're able to join us for what should be a really interesting and informative session today. For those who don't know me, and I suspect that will be most of you, I am the Policy and Public Affairs Director at the UK Marine Energy Council, or the MEC. The MEC is an industry association made up of the UK's leading tidal and wave technology and project developers. It's a role that I've held since May last year. Previously, I worked in the regulatory affairs team at Shell Trading and at the Energy Regulator Ofgem. As you will probably be aware, the last year has seen a concerted effort by the tidal and wave sector to get on the radar screens of policymakers and politicians and government in terms of the economic potential of the marine energy sector, as well as the role it can play in helping meet our 2050 net zero commitment. Against that backdrop, 2 points that I'd like to make. Firstly, the marine energy sector has been referenced in Parliament on a regular basis now, and as an organisation, we are able to call on meetings with the Energy Minister and the Secretary of State. The only reason for mentioning that is that it's all positive stuff, and it does show the profile of the sector has been enhanced over the course of the last year. Obviously, that is stuff that we'll have to carry on doing this year. In our engagement with policymakers and politicians, a key area of discussion has been and will continue to be the question of revenue support. And in this case, revenue support to enable scaling up and commercialization of our sector in the same way as, for example, wind has received over the last few years. Equally, the support that is now given to new technologies such as CCUS and hydrogen, for example. The two main revenue support proposals that the sector has been pursuing, very briefly, are reforms to the existing contracts for difference mechanism managed by BEIS. And if we get the changes that we want, the policy changes, it would enable projects to bid in this year's CFD auctions. Another proposal is a new tax-based mechanism called the Innovation Power Purchase Agreement, the IPPA, which would be of particular benefit to early stage technology developers. Now, we have seen progress on the CFD front, in this case, a restructuring of pots, and are looking to get other changes over the line in Q1 and Q2 of this year. Those other changes are primarily the strike price and a dedicated pot of capacity, a pot within a pot, if you want to call it that way, for the tidal sector. Discussions regarding the IPPA will continue this year as a matter of priority. That's at a much earlier stage, but is still a proposal that we will continue to push for. That said, and I think this is where we're getting to the meat of today's session, while revenue support is crucial to the development of the tidal and wave sector, there are other considerations that will impact on the sector's success. These include technology development and cost reduction, what's going on elsewhere with other technologies, and the net 2050 net zero target, I beg your pardon. Policy development. How does government, how do policymakers perceive the sector now, in the medium term, in the long term, as being relevant to what they want to do, delivery of their policy aims and objectives. And finally, that's my phone, and finally, what about the grid? You know, we can't think about any one particular technology, in this case, the marine sector, as being the only technology that will be playing a role in meeting our 2050 targets. It certainly isn't. For instance, you know, we will have hydrogen, we will have CCUS, we will have offshore wind, we will have floating wind. All of those technologies will make a demand on the grid. So how do we get the grid ready? Now, I'm glad to say that we have a great panel who can help us explore these and other areas of interest that will no doubt come up in the course of discussions today. Our first speaker is Magnus Harold from the Offshore Renewable Energy Catapult. And Magnus will take us through the interaction of the offshore renewable sector and the transmission grid in Wales. However, before I hand over to Magnus, can I just remind you to pop your questions down in the dialog box on the right-hand side of your screen. If you can do that in good time, then between myself and colleagues at Marine Energy Wales, we will group together the questions in an appropriate way and we'll have a Q&A session at the end of the presentations. We'll aim to get through as many of the questions as possible. One final point before I hand over to Harold, I should say, is look, for all of our panelists, and indeed for the people who are in the audience, an interesting question, perhaps we can cover at the end of the session, is if there is one thing you could change in your area of work or in another aspect of the energy sector that would help deliver either on your key objectives and aims or on the development of the renewable sector, full stop, the offshore renewable sector, what would that be? And that is an entirely open-ended question. I have a number of views myself, but it'd be interesting to get your views. Anyway, I'll leave that with you. We'll come back to that question at the end of the session. Harold, can I hand over to you, and perhaps you'd like to just give a brief background of yourself and how you fit in at the Offshore Renewables Energy Catapult?
Yes, certainly. Thanks for the introduction. Let me just pull up my screen as well, just to make sure that's working, first of all, too. Can you just confirm that you can hear me and that you can see my screen?
Yes, that's great, Magnus.
That's perfect.
Yeah, great. Yeah, so I'm Magnus. I'm Innovation Manager at the Offshore Renewable Energy Catapult. We have a team here in Wales now as of, I think, 2019, and we're growing steadily here. I've been in Wales for best part of a decade now, working in the offshore renewable energy sector here, initially in the tidal sector, but now as part of the Catapult, our work spans the offshore wind, wave and tidal sectors. If it's okay with you, Amrit, I'll just proceed now with the presentation, if that's okay.
That's absolutely fine. Yeah, looking forward to it. Thanks.
Great, thank you. So yeah, thanks also to MEW for inviting me to speak as part of this session, and for the great event that we've had so far this week. I've certainly enjoyed it. This is a project about identifying Wales's transmission network needs for an offshore renewable energy future. It's a future, I think, that we all dream about. So it's a project that we're doing in partnership with Welsh Government. We've been working with them recently on a number of studies, particularly in relation to the emerging floating wind sector. So last year we published these two reports that looked at kind of the scale of the opportunity here in Wales for floating wind, both in terms of what that opportunity could be for the supply chain, as well as in terms of actually quantifying the resource here in Wales. And so these two reports are available on our website if you're interested. But really, to kind of give a brief summary, it really just points to this golden opportunity that we have on our doorstep here. And inevitably that raised further questions in the sense of, well, how do we make this dream happen? And that led us to look at the infrastructure that we currently have here in Wales, and how that would need to change. So one aspect of this is to look at the grid, and the second aspect is to look at the ports. Today I'm going to be talking about the grid only, but the ports piece is going on in parallel to this. It's all about building an evidence base with Welsh Government to identify infrastructure priorities. I think many of you will have picked up on the fact that the Minister said that the other day, and it's all about making sure that we have the pieces in place to make the dream happen, if you like. So coming on to grid, this picture nicely summarises the current situation grid in Wales. Wales actually benefits from having high voltage transmission lines that runs across both its north and south coasts, which is also where we have these fabulous offshore renewable energy resources. So having a grid there for them to connect to puts us in a very good starting position, and it's something that can't always be said for other regions where we've got great offshore renewable energy resources. In addition to that, Wales benefits from sort of lower generation tariffs. So these are the fees that generators and project developers pay for using the transmission network in Wales. And that can make projects here particularly attractive. Recent work by ourselves, some of you may have seen my colleague Miriam talk about our cost reduction pathway project that we've just published, where it compared various floating wind projects, prospective projects around the UK, and projects in Wales actually came out of that looking quite good from an economic point of view. And one of the reasons for that is because of these lower transmission charges. But what's the problem? The problem is that the grid is already operating close to capacity in some regions, and we know that there is additional generation forecast to come online over the course of the next decade, and probably will get there before floating wind does. So this study is looking to identify where these constraints are, what the required upgrades will be, particularly if we want to deploy offshore wind at scale. And this study actually is looking at both fixed and floating offshore wind scenarios. Okay, so when we look at the grid in Wales, we sort of need to separate Northern Wales out and look at those independent of one another, purely because they're operating on different circuits, and from a grid point of view, they operate behind different boundaries. So if we start with North Wales, there's huge potential for new fixed bottom offshore wind in North Wales. Of course, North Wales has got a strong history there already, having developed some of the first offshore wind farms in the country. Last year, the future looks bright, and last year we had the announcement from RWE that they're going to be extending the Gwyntimore wind farm. That's Wales's largest offshore wind farm. That's going to be a project known as Owlymore, and we'll see at least another 576 megawatts plugged into the North Wales grid before 2030. But in addition to this, we have the North Wales featuring in the offshore wind leasing round 4, which is currently live, and we're fully expecting more projects to come through this process. It's not all about fixed bottom offshore wind in North Wales though. Not shown on this map, but the region to the west of Anglesey, for example, is particularly attractive for floating wind. And for those of you that saw Alex Meredith speak yesterday from RWE, he actually mentioned this region as being an area of interest to them for a floating wind stepping stone project. So that in this study, we're looking at adding, we're looking at 3 future offshore wind scenarios for North Wales. These range from a low case to a high case, ranging from adding 1.4 gigawatts to almost 7 gigawatts to the North Wales grid. Moving on to South Wales, it really is all about the Celtic Sea and floating wind in the Celtic Sea. I mentioned a prior study that we did last year with the Welsh Government, and that identified that as much as 50 gigawatts of potential exists in the greater Celtic Sea region, so including the southwest of England in that too. And we do have a pipeline here as well. Blue Gem Wind, as many of you will know, set to install the Celtic Sea's first floating wind project before the end of the decade. That's the Erebus project, 96 megawatt test and demonstration project. We're fully expecting kind of pre-commercial scale projects of the order of a few hundred megawatts to follow, and then going into the 2030s, really gigawatt scale developments in the Celtic Sea. So again, 3 scenarios for South Wales, ranging from 1.4 gigawatts to just over 10 gigawatts. You might be looking at these figures and thinking, that's an eye-watering amount of offshore wind, but you have to remember that we're striving for 75 gigawatts in the UK by 2050 if we are to achieve net zero. And it's good to be ambitious in studies like this. So naturally, any kind of work that involves the grid involves a lot of grid modeling work, power flow analysis type work. We're ITP Energize, we're working with them. They're doing all of this work in the project, and I just wanted to briefly acknowledge that and thank them for the great work they've done to date. And naturally, when you do a project like this, the goalposts tend to move around quite a lot, and they've been very accommodating of meeting our needs there. So they've built up a network of the grid in Wales, and adding to that network other things like what else is coming online in the future. So things like the Morelice Tidal Energy Project. We've got new interconnectors planned for both North and South Wales. These are interconnectors between Wales and Ireland, as well as incorporating things like future electricity demand projections as we move to an increasing electric future. Just as a side note, we also have a kind of alternative future for North Wales, where we have a new nuclear scenario, given that there is huge potential for new nuclear in North Wales, and it's something that keeps being talked about and could have quite a big impact on a study like this. We thought it was important to cover all bases there. The next step of the work that ITP Energize is doing is to look at, obviously we're trying to add gigawatts of power to the grid. That's not possible at the moment unless we upgrade it or reinforce it. So they're looking at solutions by means of a cost-benefit analysis. That includes comparing onshore solutions where you might sort of reinforce existing lines by reconductoring them, or by building new circuits onshore, comparing those with more like offshore solutions where you can, for example, bootstrap one part of Wales to another part of the UK via a HVDC link. So these are being weighed up against one another. But to summarize, the project's looking at trying to find the no regrets options, and particularly in relation to key bottlenecks. Unfortunately, I don't have any results to share with you today, but we are expecting to have those soon, with the final report due to be published by the end of February, as well as the port study that I mentioned earlier. That's all I had to say on that. So thanks very much. Do post your questions in the chat, as Amrit said.
Magnus, thank you. Thank you for that. That was excellent. I really enjoyed that. There are a couple of questions that spring to mind, which I'll leave until the end. But I was rather taken with your comment about low transmission tariffs, and I just wonder how long those might last and might not. So it'd be interesting, I think, to cover that one at the end, because clearly those types of charges are subject to change every so often. So let's keep that in mind for the end of the session. Anyway, thank you for that, Magnus. I will now hand over to Tim Warren from Bayes. Tim, I'll give the floor to you. Perhaps you'd like to give a quick introduction to yourself, a bit of background.
Yeah. Very much, Amrit, and thanks to Marine Energy Wales for this invitation. It's a pleasure to be with you today, albeit virtually, somewhat semi-detached. I'm Tim Warren. I'm a senior policy advisor at the Department for Business, Energy and Industrial Strategy, a name so long that I sometimes lose my way halfway through it. I am, among other things, responsible for marine energy at Bayes. My directorate looks after renewables in general, and in particular the Contract for Difference scheme, which is the primary support mechanism for renewables. Turning to our theme for today, clearly net zero is a major challenge across all sectors of the economy and right across the UK. Let's not forget, though, the progress that has already been made. Between 1990 and 2018, UK emissions fell by 43%, while the economy grew by 75%. We have about another 30 years to repeat that trick, and then some. So it's a huge challenge that we face. As the Prime Minister recently said, we need a green industrial revolution in order to bring about this comprehensive transformation to a net zero economy. Now, my area, as I said, is the power sector, which has been arguably the top performer so far. But demand for power is expected by 2050 to double, and therefore low carbon generation capacity will need to quadruple or more. As a start to that, we are doubling our ambition, as the Prime Minister announced, for renewable capacity in this year's CFD allocation process from the last one a couple of years ago. Offshore and floating off wind obviously hit the headlines, but the other renewables technologies is also needed. Sometimes the phrase low cost is added to that phrase. Now, it's understood that low cost does not mean cheap. Offshore wind has come on a massive cost reduction journey over the past decade, and that's been driven by clear government ambition and competitive support on price. And that is the model to which the government is committed in terms of this massive challenge that faces us. If technologies such as floating offshore wind, wave, and tidal can demonstrate deployment potential, cost reduction, and wider benefits, then they deserve a route to market and challenge. Now, just in passing, I'd like to mention that we work very, very closely with the Crown Estate on issues of seabed licensing and regulation. We are particularly keen to see the development of offshore renewable energy hubs, and they are super important, and sort of particularly developments in Anglesey are very exciting in that regard. And also, we are committed to net zero energy networks, and obviously work closely with Ofgem, with National Grid, and with other network owners on ensuring that the networks too rise to the challenge. And finally, we are and our ministers are very much interested in the wider supply chain, and their desire is to ensure that as we sort of embark upon this challenge, as we work towards net zero, that local communities, local areas are getting the full benefit of not just direct jobs and growth, but also of export potential in technologies where the UK has something of a lead, and that certainly applies to the marine energy space. So during September of last year, most of you will have noticed that we ran a call for evidence on marine energy, and we collected an excellent set of responses, over 200 responses to that call, whether that's from developers, from academics, from suppliers, from trade associations, and many others. Now, this is a marvelous resource, and I can tell you that on pretty much every week, I'm diving into that evidence base and doing another search to check up on something. So that's where we are, and we're committed to engaging with the different sectors in order to ensure success in this endeavour on which we're. Thanks, Emmerich. Back to you.
Tim, thank you for that. That was excellent. That was really, really interesting. Before I hand over, or before I hand over to Chris, I should say that I was particularly taken with your description of the CFD mechanism. And I think the 3 points I noted were, the idea of deployment, cost reduction, but also the wider benefits of development of our sector. So I'm sure that is something that we will come to in the course of the Q&A session at the end, but it's good to hear. Excellent to hear. I think our next speaker is Chris Williams. Chris, can I hand over to you?
Hi, I'll just share my screen. Can you see that okay?
Into full screen. Yeah, that's perfect. On full
Got
screen.
me worried there.
Thank
Hi, Chris Williams. I'm going to talk quickly through the developing South Wales industrial cluster. It's recognised as an industrial region, as both South Wales is, by UK government, obviously, in terms of the diagram on and the infographic on the right-hand side. And this came out of UK government understanding and developing how it gets its industry to net zero. And then you come up really with the conclusion that there are a grouping of industries which are classed as the difficult to decarbonise industries. And this challenge is focused on those industries in particular. And we have a grouping of those industries in South Wales, or a cluster. And the objective of this project, this grouping of individuals then that represent those sectors of industry, so steel, cement, chemicals, oil, is to work together through symbiosis, through the use of hydrogen and through the use of CCUS to explore, develop and implement net zero technologies. So it's a regional grouping of industries, representatives from those industries, working together with network providers, energy providers as well, on determining routes to net zero. We're at the start of our journey. There's a whole host of industries as part of us. We're not a formal entity yet. We're a sort of informal grouping with a steering team, setting about creating that entity and working out the best way to do that for Wales and for South Wales. We've got obviously industrial grouping, we've got academic grouping, we've got an academic lead through Swansea, Cardiff, University of South Wales, mainly through the sort of Flexis project and the RICE project, Reduce Industrial Carbon Emissions project. And also then we're trying to work on how we understand and interact properly with governments in terms of the 14 local authorities that span between Milford and Newport, the city deals, and also working closely with Welsh Government. Of course, outside of that, we have close working relationship with BEIS through the cluster engagement team. So in terms of industry, we've come together to form a team, and then in terms of industry, it's going through the sort of technological options that the industrial sites have to decarbonisation. So in terms of looking internally at energy efficiency, understanding then the options within each site for fuel switching. So can we fuel switch away from natural gas to electricity, so electrification, or to hydrogen, or to maybe biofuels? What are the options within that? So you would think it's likely to be hydrogen primarily for higher temperature applications. The development of smart networks, so that's symbiosis with society and other businesses local to those industrial sites. Carbon capture utilization, so that's turning CO2 into another use through chemical make or fuels, or using it directly as CO2 for processing. And the last option then, of course, if we're still producing CO2, what are we going to do with that CO2? And that's where carbon capture and storage potentially comes in. So we'll be exploring that for what we're calling mini clusters, really, in terms of Milford Haven, Swansea, Barry, Cardiff and Newport. So if you take each individual site, of course, you consider those options. So let's consider fuel switching to hydrogen. Of course, the biggest question then is, where's that hydrogen going to come from? And where's the renewable electricity going to come from to make that hydrogen? Is that hydrogen going to be blue hydrogen or green hydrogen? How does that all fit in to the region? So in parallel to those steps, we'll be exploring sort of infrastructure and supply. So electrical distribution, hydrogen supply, low carbon electricity generation and supply, and of course carbon capture and storage through local hubs, mini clusters underneath the main South Wales industrial cluster. So within this sort of investigation, We'll be working with National Grid, Wales West Utilities, Western Power Distribution, and obviously the energy suppliers. And of course, that's where us mapping out as industry our future will help the network providers understand what we're likely to need, which always iterate then as well back to us in terms of us determining what our options are. There's no point us exploring hydrogen conversion of, let's say, a biscuit factory in Cardiff when nobody's working on getting hydrogen to that biscuit factory. So there needs to be an iterative, a proper team effort in end consumers from an industrial perspective, to energy suppliers and energy distributors. So this sort of pathway will help us form the teams and start us developing a strategy for getting to net zero. And of course, in parallel to that, as part of the BEIS expert work groups, so the business models for hydrogen supply, for hydrogen conversion, for hydrogen use, for carbon capture, utilization and storage. The business models, of course, will provide the investment framework really for us to start to make some of these a reality. And then when you look at the sort of South Wales industrial area in terms of, obviously, what the steelworks in Port Talbot, oil refinery in Milford Haven, chemical plants around Barry, in Newport, we've got steel making again. Of course, we've got breweries, we've got chemical plants dotted around the place, our food manufacturing, drinks, breweries, all sorts of things that we're trying to tie in to understand and develop their own individual strategies, but also then how that fits into a regional picture. So you can really start to see how South Wales can be the hydrogen gateway for the southwest of the UK, with growing renewables capability. We obviously start to develop the market, I suppose, for, or at least an understanding of the market requirement for the scale of renewables as industry becomes more electrified, as it seeks more and more green hydrogen to come from renewables. But also in the shorter term then, how do we maybe accelerate the hydrogen economy more locally by maybe exploring the existing LNG import terminal, converting those maybe to generate hydrogen as well, so we can start to accelerate the hydrogen economy as the renewables develop and grow in capability. So at the moment, we account for maybe around 16 million tonnes in terms of industry and power generation in South Wales. So if you will look at sort of a balance of scales, and we're going to focus then on our 5 steps for each industrial sector in terms of industrial decarbonisation. Obviously, we're looking then to how we get from there to balancing to a net zero, and underpinning that, of course, is low carbon hydrogen supply and low carbon power supply. So I think I was invited along to this panel. Thank you very much, Marine Energy Wales, to just sort of show the wider context of what industry is doing, and power generation is doing, to try and understand its future and try and map out what the future energy network might well be, working with National Grid, Wales West Utilities and Western Power Distribution. And I think that's me.
Chris, thank you for that. That was really, really interesting. Just a couple of takeaways from my perspective before I hand over to our next speaker is, I remember many years ago, you mentioned the LNG import terminal. It's amazing how times change. I remember a few years ago, I actually worked on the import terminal, the LNG import terminal in South Wales. And to think just a few years later they could be used for hydrogen production goes to show how times have changed and the quickening pace of change in our sector. I think the other takeaway for me was just the very detailed explanation of this being a partnership, and the fact that you do have to be engaged with the grid operators to make sure that they know what's required when it's required as well. So that's maybe something that we can take away as we look rather at the needs of the tidal and wave sector in the years to come. But thank you for that, Chris. That was really good and really, really informative. Next is over to Matt. Matt, can I hand over to you?
Yes, certainly, Emric, and thank you very much. Just share my screen in time-honored fashion. So hopefully everyone can see that. Okay, so I should be on full screen. Manon, could you give me a yay or a nay?
Yeah, perfect. It's on full screen. Thanks, Mike.
Fabulous. Thank you very much. Well, firstly, thank you, Marine Energy Wales, for the invite. It is an absolute pleasure to be with you all, although virtually. I have to admit, I was very much looking forward to being in London right now, but there we go. Hopefully next year we can all get together and see each other in person. But for now, it's great to be here. My name is Matt Hodgson. I'm here on behalf of WaveHub Development Services today, and we are behind the Pembrokeshire Demonstration Zone project, which I'm going to touch upon through my slides. My actual role more broadly is working on economic development with a real focus on marine renewables and marine technology in Cornwall, and yeah, that's my background is in that area, and I'm happy to talk about that when we have more time. But what I'd like to sort of work through today, we're talking about how do we get to a point beyond revenue subsidy, where what are the factors that are going to impact on pace and moving us to that point. And I wanted to sort of think about that a little bit sort of broadly, and then just focus in on specifics about how we might start to look at that in Wales. I think broadly speaking, scale, if we look at the example of offshore wind, there's no two ways around it. An increasing scale results in cost reduction, and there are a number of factors for that which we all know. And that's what will take us to that point beyond revenue subsidy. And for those who haven't seen it, I would recommend reading the Catapult's report on cost reduction on floating offshore wind, which was published yesterday. It's a really good piece of work and provides some excellent pathways. From my point of view, and sort of bringing it into the waters off Wales, the Celtic Sea in particular, I think there's a really interesting opportunity in front of us, because it's essentially a blank sheet canvas. We are at a point in time, I think, where there are real developments in floating offshore wind, where there is a solid marine energy industry already here, and yet we're not where we've got to get to in the next few years. There's not the danger, or we can try and avoid some of the dangers of ad hoc development. And so there's an opportunity to think strategically and holistically around areas like site selection, impacts, cumulative impacts, and the consenting process, in parallel with thinking about grid connectivity and how do we make sure that we're maximizing our resource areas and making the best of it. And also thinking about infrastructure, our supply chain learning, and creating the industry in the UK so we can meet our local content targets. That for me, it's a great opportunity to think holistically. I think in my experience, there has always been a little bit of chicken and egg and circular arguments. Developers won't commit until consenting processes are well known, or until revenue subsidies are well known, and port infrastructure won't get built until there's a demand. And we go round and round the circle, there's a great opportunity here to think together about how we achieve an industry which is subsidy free and which is meeting our net zero targets and is delivering on industrial growth in Wales. As part of helping that challenge, I am going to name check the Pembroke Marine project, which we're part of. It's a £60 million project supported by Swansea Bay City deal and also ERDF funds from WEFO. And I think it's a great example of collaboration across a number of different areas to actually think holistically. So we're looking at the consenting, the resource areas, we're looking at technology development, looking at port infrastructure, and also looking at some of the engineering challenges together over the next few years. So I'm sure my colleagues in Marine Energy Wales have brought this forward in another presentation, but I don't think it devalues the project by mentioning it as much as possible. So the Pembrokeshire demonstration zone element of that project has evolved over the years from its original plan, if you like, into something which has a real potential to act as a sort of key driver, not just for Wales actually, but I think nationally. Originally, it was a lease site. It is around 20 kilometres south of Pembroke Dock, and was originally scoped as a wave energy test area. It still is, but it's also been looked at as potentially a good site for technology testing for floating offshore wind. And in all reality, actually, marine energy testing into the future, there's a whole range of options there for follow-on testing as technologies move up through the technology readiness scales. But the key point I'd like to sort of delve into, and the key element of this project is the electrical infrastructure, the connectivity of that site. Because it became quite clear, I think, that if we look at connecting into Pembroke, we're one of a number of potential projects that wish to connect into the grid supply point there. And I don't think we're alone in thinking that having multiple cable corridors, landfalls, onshore infrastructure and connection agreements is anything other than hugely inefficient. There's the potential for avoidable cumulative environmental impacts, that long planning delays, and not to put too fine a point on it, it's pretty expensive. Now, Ofgem and National Grid are really sort of looking at this now quite aggressively, I think, and there's some work streams going on, which James may touch upon, looking at things like multi-purpose interconnectors and thinking about ways to aggregate develop aggregate connection points and to solve some of these challenges. And just going right back to my original point, Celtic Sea and the waters around Wales are a really fantastic area to sort of think about tackling this from first principles, because we don't have lots of projects already connected. So I think that's a great opportunity. So a very simple schematic. It would be quite wrong of me to suggest that is anything other than a concept. But the project will be kicking off very shortly, and we'll be starting to sort of work on technical feasibility, consenting, and industry engagement, and then design work to see what the art of the possible is for this type of connection. Why do we want to do that? Because we think it's got the potential to really catalyse floating offshore wind developments in Welsh waters, but it also future-proofs the demo site in enabling us to connect future technologies as they come through and into that testing arena. Finally, I think it's got the potential to act as a sort of first of a kind and an exemplar system, which really does fit into sort of the national requirement. Really excited to see how that one goes. I'm really hoping that we can get moving with this in the next few weeks, and when we come back to speak to you next year, hopefully in Llandudno or one of the other wonderful Welsh venues, we will have moved things forward quite considerably, and we can have a bit more of an interesting discussion. So a quick gallop through, but I'm conscious trying to keep to 6 minutes. So,
Matt, thank you for that. I must say, I think I'm not sure whether the more efficient way forward would be effective an extension of National Grid to become an offshore operator as well, or whether you create a new National Grid, just concentrating on the offshore. So that could be certainly one for Ofgem and for BEIS to consider over the course of the next couple of years. It's horses for courses, but I dare say that it will keep folks busy. But thank you for that. Really, really interesting stuff, Matt. As I said, lots to consider going forward. We are now going to be, I think, our very final presentation, and oddly enough, given the content of Matt's presentation, I think it's quite apt that we now hand over to James Greenhouse from National Grid Electricity System Operator. James, over to you.
Good morning, Amric, and thank you for that introduction, and thank you, Matt, for the references to National Grid throughout your presentation. I hope the content of my presentation doesn't disappoint. The one thing I would bring up just before I start, though, I'm not actually presenting on integrated offshore and multi-purpose interconnectors today, but I can certainly talk a little bit about that as we go. So thank you to Marine Energy Wales for inviting me to speak today, and thank you to everybody for joining to participate in this session. My name is James Greenhalgh. Thank you, Amric, for the introduction. I'm responsible for grid connections across whole of GB onto the transmission network, and the connection offer process and the grid code compliance process that goes with getting projects all the way through from initial inception through to operating on the network. So today I'd like to talk to you about who National Grid Electricity System Operator are. Just to pick on Amric's point about a new system operator, you might not be surprised to see my preference would be that this would be an extension to existing responsibilities. And I was quite delighted actually to sort of hear the outcome of the recent review by Ofgem at the beginning of last week. So all good news, but let's see where that plays out over the coming months and years. I'll talk a little bit about where we sit in the industry. And particularly about some of the changes in the industry that surrounds where we sit, but why our role is still quite so important in terms of where we are. The connection journey I'll talk about, hopefully that will be of interest to people who are developing projects, how you get your project from first thoughts and bringing the idea to life through to connecting to the network, and then a little bit about the work that we're doing to facilitate our part in achieving net zero and the ambition that ESO has put out there towards getting to a carbon-free grid by 2025. Apologies, I'm going to have to keep asking Manon to move slides for me because I'm the one out of the group that doesn't have the technology ability today for whatever reason that is. So Manon, would you mind moving to the next slide for me, please? Thank you very much. So just to kick us off, and for some people probably you're all too well aware of this, but perhaps just a bit of a reminder for others as to where National Grid as the electricity system operator sits within the grid system itself. Starting with the physical aspects of our role, our primary role is to essentially operate the electricity transmission network. The network itself provides that sort of transportation route for bulk quantities of power, as you can see on the left of the slide. You know, what is left of the old huge generators that have been built up over years around the country, and that are slowly being replaced by offshore wind farms, onshore wind farms in more remote locations than where the grid was originally developed. And so on and so forth. Essentially, the large quantities of megawatts that are created to bring power into our homes in a much smaller and safer fashion, in a way that we are all familiar with in a day-to-day perspective. That power, obviously, on a transmission network itself, goes through to industrial loads, transportation systems like rail, etc. And then ultimately through the distribution networks to land with us in our homes. The role of the system operator being to ensure that that power transmits across that boundary and that network from wherever it's being produced around the whole of Great Britain, and landing with us today. Now, clearly one thing you will all see, people who are here today will be familiar with that changing background of where power is coming from, the types of generation and technologies that we're seeing coming onto the system today, and where that connects, and not least in Wales, the sort of difference in where that power is coming from the old heady days of when power was produced in the southwest corner, with all the fossil fuel generation, to a world today where we envisage much more wind embedded across Wales, and certainly around the coast and the offshore coast. Thanks, Manon. If you could perhaps move to the next slide for me, that'd be great. Thanks. So National Grid's role, having seen where we sit in the industry structure, our role itself is about balancing and operation of that network. The balancing that we do essentially requires second by second matching of supply to demand to make sure that just the right quantity is there to be used. And we do that across the whole of the network. Obviously, power exists all around the coast of Britain today, in addition to the existing power generation that's been there at the main generation centres, in particular around the northeast and the northwest of England. We facilitate balancing by essentially, connecting that generation, widening access to the network for people who want to bring generation forward, and developing market tools that essentially allows people to participate in the market, provides an opportunity for people to provide services that we need to help balance the network, whether that be power turn up or turn down, or providing sort of more reactive type products that we use and are growing in popularity as we move forward. This gives us a great opportunity to promote competition itself in the energy market, by creating opportunities, creating visibility of the needs that we have on the network to operate it, and to identify those requirements as we move forward. In addition, one of our roles is to identify requirements for network reinforcements today and in the future. We see as the source of generation changes in its location significantly. The way that power flows across the network has changed significantly over the years. From the past, the flow was predominantly from north to south, from the sort of coal fields and areas where there was lots of gas-fired generation, to the main load centre, which is clearly in the southeast and remains that way today. But the source of that generation, where it's coming from, is obviously very different, and that has an impact on the way that the network behaves and the way that we have to operate it. We plan the day-to-day operation of the network, providing access for the network companies to get access to the network equipment that they own, for maintenance and also for connection of new networks. And ultimately, we are also the contract party for anybody who's connected to the transmission network. So any generation that is connected onto the network has a contract with the electricity system operator, which runs from sort of initial discussions around how and when and where to connect, right through the operating life of that asset. We administer the charging and the billing for use of that network, and that ensures that the transmission and distribution network owners receive the payments that they should receive from people who are connected to that network. Thanks, Manon. Could you perhaps move on, please, for me? Thank you. So I thought I'd talk a little bit about the connection journey for people who are not familiar with that, and for anybody that is, it's a bit of a reminder. Essentially, there are four sort of main parts to the grid connection journey. There's the application phase, where in many cases our conversations with developers start at the very early stages of a project's concept. In some cases, more established businesses and projects are already further down the line, but in many cases we also see people who are just starting out wanting to develop a project and bring it to the grid, and that provides the opportunity for us to have what we call pre-application discussions with those developers, explain how the process works, talk about the timescales and the costs associated with that, to ensure that before they bring those projects forward and they invest large sums of money, that they understand what the process looks like and the timescales involved, and who the various actors will be involved along the way. We have the offer period itself, which is essentially a sort of 6-month period where, having worked on producing an offer in the initial first 3-month period, the customer is presented with an offer and has a further 3 months to essentially agree the terms of that offer during the post-offer negotiation phase, and then we move into the construction and the connection process. Throughout these 4 stages, there's a lot of opportunity for interaction between the ESO, the customer, and the relevant transmission network company. In many cases, lots of projects take many years to come to fruition, and already today lots of people have spoken about planning challenges, the construction process, the various regulatory frameworks that determine how long reinforcements can be built. These things all go towards helping getting through a successful project from a perspective of delivery. For us in National Grid, the process has been highly active really over the recent few years. Historically, there's always been lots of activity in transmission. I would say that in the last 2 to 3 years, we have seen a huge increase in that volume. Essentially, the last financial year, we've seen around about 650 applications for connection to the transmission network. Compare that with sort of 2-3 years ago, where we were looking at around about 350 applications. Significant increase. I think for me, the fundamental thing here is that it's the types of connections that we're seeing coming forward that are changing significantly, and creating a great opportunity for us to do our job in a different way and creating interest for us. The technology that we're seeing coming through the network and the range of customers that we engage with on a day-to-day basis, all have significantly changed. So far less of the fossil fuel type generation that we saw of the past, far more wind, battery storage. Technology developments in battery storage has been impressive over the last few years, and we've seen many applications. Solar, offshore wind, as you would expect to see, and far more interest from the marine sector too, in addition to interconnection from various places. All of this is sort of for us is a clear representation of how that ambition of reaching net zero is really starting to take hold and is gathering momentum on the ground in the connection space. Manon, could you move on for me, please? Thank you. So that movement towards that net zero ambition has caused a huge opportunity for the ESO to put a stamp on a commitment to help achieve that in the energy space. And the ESO has created its own ambition to essentially get to a world where we are able to operate a zero carbon network by 2025. And essentially what that means for us is that we have carbon-free operation of the transmission system for essentially medium to extended lengths of time. We need to be ready to accommodate the types of zero carbon electricity generation that's coming forward, and we need to be in a place where the network itself is able to respond to the different types of generation that's coming along. There are many challenges to us presented to us in getting there, but we have sort of seen over the last few years a consistent, regular sort of momentum of change in the types of generation in the background, and so we're preparing for those challenges almost through doing, really. I've got some notable records up on the slide there. That on August the 17th, you can see that we were 88% zero carbon on the network, which was a pretty fantastic opportunity. In terms of challenges, the types of generation that are coming along, the technologies involved are different to what we've been used to over many, many years, and they continue to change. And the way that the network operates tends to present us with challenges day on day. So frequency management needs to be carried out in a different way, because the way that the new types of generation respond on the network behaves very differently to what we're used to, and the market itself has not been established in a way in which we can respond to the challenges that brings very quickly. So we're working with the industry to sort of help develop that space. Inertia and voltage support, equally areas where we've seen significant changes over the last few years as the quantities of low carbon new non-synchronous plant has started to increase on the network. So many challenges that we've faced, but we continue to, and we've sort of, as I say, we've stepped up, identified that a commitment to operate the grid zero carbon by 2025 is in our sights. Perhaps if you go on to the next slide, Manon, please. Thank you. So I talked about these challenges and the things that we're trying to do to enable us to adapt to those challenges. Many of you will be familiar with some of these products that I've got on the slide here, but the tools that we're bringing forward include pathfinders to deal with stability, voltage, and constraint management. Stability pathfinder projects being something that we need to help us maintain the strength of the network is probably the best way of describing it here. We are no longer in a world where we are generating megawatts from large traditional types of generation, heavy plant that naturally provided stability of the network for us. So we are trying to develop market signals to provide technology solutions where we can provide stability through technology solutions onto the network. We're in the middle of the second stability pathfinder at this point in time, working with industry, having lots of challenges and lots of interest coming forward from various technology producers. So working well in that space, and all the time giving us confidence that the concerns that we had about the stability of the network are solvable through different solutions than we've been used to. Voltage is another area where, as technology has changed, we've seen a different way in which we have to operate the network. We have a voltage pathfinder that is working with both existing network owners as well as new technology providers to provide us with voltage support in areas of the network where we start to see issues. Traditionally, voltage support would have been provided by equipment on the network, but also inherently from the generation that existed on the network. The location of that generation has changed, as I've discussed in the previous few slides, and therefore the voltage issues start to materialize in different places. Voltage support is not a product that travels well on the network, so you can't just plonk it in the north or the south and hope that it works. It needs to be managed at a very local level. And so Voltage Pathfinder is a product that we're developing with various providers at the moment. And constraint management, again, another product that we need to develop with various providers to allow us to operate the network. This in particular becomes interesting when the location of the generation that we talked about previously changes significantly, and the previous construction and the nature of how the network was built to cope with flows on the network is no longer reflective of where the generation is coming from. So whilst the load centres still remain in the same place, the location of generation where it starts is now different, and that presents us with almost, well, we call them constraints, just areas on the network where power is restricted in the volumes that can flow across various boundaries on the network. There are various methods that we can use to strengthen those boundaries, and that includes employing technology solutions on either side of those boundaries. Batteries is a great example, where essentially you can charge the battery on one side of the constraint boundary in a period of time, and then release power from it in another period of time when the constraint bites in a different direction. In addition to those Pathfinder projects, we also have some frequency management products that we're developing. Dynamic containment is a particular product that helps us manage the changes in load demand on the network. Essentially, this provides us with an opportunity to access flexibility from products lower down in the network, along with the ODFM product, which is the optional downward flexibility management. This is a product that helps us to work with customers on the network who wouldn't previously buy and sell power through the national grid balancing mechanism, because they are so deeply embedded within the distribution networks. But this product helps us to access flexibility services that they can provide to help us manage the network day to day.
James, sorry to interrupt you. We're just going over time a little bit, and we've got some brilliant questions coming in on the session chat that I want to make sure that we get to. So if you could wrap up, that would be really great.
Thanks, Manon. I can do that. I can skip on. These slides are obviously available for people to have a look at. I will just move on then to the last slide, actually, Manon, because essentially this really wraps it up from our perspective. As we've all kind of familiar with, we have got a huge rapid movement towards decarbonisation. Hopefully my slides today, my presentation, sort of brought to life the volumes and the changes that we're seeing. The SO has sort of set itself some very ambitious targets to be able to operate that network, and we're going to do that hand in hand with the industry, using new technologies, using the existing networks that we've got, but also identifying where we need to build. I'm going to stop there, otherwise I could go on all day, but thank you. And thanks, Amrit.
James, thank you for that. I know we went a bit over time, but I think that was really good, interesting stuff. And I suppose it's important to highlight that while National Grid obviously has the obligation to connect, it also has a number of other regulatory requirements, in this case, economic and efficient behaviour. It's also got a number of choices it has to make, and all of that has to be done at the same time. But it is effectively shifting the grid from being a north-south, maybe to more east-west and different types of connected parties. So I think it was an excellent way of bringing all those competing requirements to the fore. But we have got a few minutes for, I think another 7 or 8 minutes for questions, and we've got a few here. In the interest of time, and please forgive me, but I will try and summarise some of the issues that have cropped up in these questions, and hopefully that should get most of the questions answered one way or another. Magnus, if we go back to your presentation and the reference to generation tariffs, so transmission tariffs in Wales, I'd be interested to know, for instance, how you take into account the fact that those tariffs will change, and how that's taken into account in your modelling, and also the extent to which, for instance, the current regulatory and charging framework is stable enough to be able to make those judgments.
Yeah, certainly. Unfortunately, the developers don't have crystal balls, and you know, they kind of sign up to these projects not knowing what the charges are going to be in the future. Generally, at the moment, the charges go up in regions that have more amounts of renewable generation because of the increased costs of operating that generation. We have done it internally, and as you know, Matt mentioned earlier, the cost reduction pathway report that we've just published. We do tend to look at the sensitivity. We can do that in our sort of LCOE projections. And one of the interesting bits that came out of that was that you know, there's floating wind projects being proposed in the northeast of Scotland, and right now the sort of tariffs are forecast to increase quite a lot in the northeast of Scotland, and I think the study sort of suggested that the effect that would have on the LCOE of floating wind projects in that region could be affected by as much as 7%. So it's not insignificant. It's definitely something we can quantify, but unfortunately, when you sign up to these projects, you don't really know how it's going to change in the future.
Well, it was always the way, I think, with any project, be it the ones we talk about now or in previous years, various electricity and gas projects as well. So it's a challenge, but certainly I think it's something that the industry or our sector will have to become aware of, the fact that, you know, these charges will change and it's very difficult to actually model how they will impact over the course of an asset, which may be 35, 40 years, even longer, I think. So that's an interesting challenge for the industry and one to be aware of. On the question of connections, and again, there's another question on this particular subject. James, if I come back to you, you gave a very detailed presentation on the whole connections process and how that works. I think it'll be interesting to find out how you actually calculate and how you actually work out what the connection charge will be. So if somebody wants to connect, what will they be charged for?
Yeah, Amrit, that's a great question, and I'll probably just link a little bit the answer to Magnus's question too. I mean, essentially, I spoke about the sort of changing nature of where generation is on the network, and how that's changing the way that the network does operate. But alongside that, it's probably really important to note that whilst a lot of the location of the generation is changing significantly, and that is a huge driver on the cost for connection to the network. The load centre for Britain is still predominantly where it always has been, and that means that the way that the network has been built to transport power into the southeast still works in that particular way. As you've seen in Scotland, we've had a huge increase in the volumes of renewable energy in Scotland over the last 10 years, and that is set to continue. But it's clear that the sort of transmission network itself has not been increased significantly to transport that power, and it's the cost of using that network and getting the power from the source of the generation to the load centre that drives those charging mechanisms that we have. For me, the bit where we need to sort of address this and deal with the challenge is the fact that historically, the sort of organisations involved in developing power stations and using the network as it exists were very large organisations, and transmission charges and connection charges were quite small, really, in terms of their ability, the comparison for the size of their networks. However, what you see today is far more small developers with much smaller balance sheets coming forward wanting to connect, and so the impact on them and the ability for them to develop those products is more challenged because of those transmission charges. So, I mean, really, the charging methodology is about the amount of reinforcement and the amount of work required on the network in order to transmit the megawatts to the load centres, and those are sort of fundamentally driven by where power is used and where it's being produced. So to a certain extent, that sort of would be set to continue in the existing model for charging. My view is that maybe a review of that and a way of identifying a more fair way of charging might be more appropriate.
Right. Okay.
Sorry, I'm just.
Are we out of time now? Are we?
No, I'm just going to say we've extended this session to 25 past just to allow for a few more questions. So
right.
We've got another 10 minutes to, for the questions. Thanks, Amrit.
Excellent. There are a couple of questions. Tim, you don't get off lightly, so here's one for you. In your presentation, I did note that you spoke about the CFD mechanism and the sorts of factors that you take into account at BEIS, not you personally, but at BEIS, take into account. Competition was there, obviously, value for money. And you mentioned the wider benefits the technology could bring. Now, one of the many good, one of the key points about the marine sector is the wider benefits it brings, not just to the energy network, which we'll pick up with James in a moment, but the wider economic benefits that it would bring to the country in terms of levelling up, in terms of regeneration of coastal areas. How do you take, or how does BEIS take that into account when it considers the role of marine and CFD?
We put effort into assessing value for money of both sort of freestanding interventions into the market and also building on existing programs. As we're looking at the moment at the strategic case for tidal energy with a view to net zero, we are looking to to kind of cover off all of those areas, looking at deployment potential, cost reduction potential, but the sort of value added to the economy, both in terms of UK deployment and potential future exports activity. So we have what used to be called the TINAs, the Technology Innovation Assessments. We have those that enable us to interrogate the sort of economic opportunities both locally and in terms of exports. So we're committed to doing that, and I think we also recognise the value of marine energy in terms of a diverse electricity mix. You know, if we're going to be having a power sector that's possibly twice the size, twice the demand, and if that's going to be mainly delivered by technologies, which is certainly the expectation, and not just of government but also of many commentators, then we're not going to want to see that all in one technology with one kind of exposure to weather conditions. We want to see diversity there, and you know, the key benefit of wave and tidal technologies is that they are, broadly speaking, uncorrelated with, say, wind, with solar, with hydro, and so contribute to the ability to operate the system. And I'm sure James would be unhappy to have his zero carbon energy network entirely driven by wind. So he would like to see a few different sources in that mix, and that's kind of very important as we're looking at strategy going forward.
Excellent, thank you. I think we've got another 7 or 8 minutes, so I just want to remind the panelists, I did pose the question at the beginning of the session, you know, what one thing would you like to change? So I'll be coming to you all for an answer to that question in a moment. A couple of just quickies here. One for you, Tim, from Oliver at Orbital. Any news on the response to the call for evidence? And when will they be announcing the updated plans?
Yeah, no, good question. And hi, Oliver. As we said in the call for evidence itself, our intention was to respond as part of the Energy White Paper. Now, that response is a very kind of high level one. We are continuing to work on the case for marine energy more generally, and tidal stream in particular, and we're feeding into the design of the allocation mechanism for the fourth allocation round towards the end of this year. So we are continuing to work on that. So we're hoping that we'll be able to announce more as the year progresses. But in terms of a formal government response, the Energy White Paper is it. Okay.
All right. Thanks for that, Tim. I have, before we go to that question that I posed at the beginning, James, a very quick one for you, and perhaps this might, a bit of an advertisement, but I think for tidal, I expect Tim to be looking at this as well. James, operating the network, and you have a number of tools available to you, and bearing in mind the challenges posed by intermittent renewables, and we've seen over the course of the last few months, you know, negative prices, for instance. What value do you place on, for instance, the predictability of energy sources and how they would help you manage the network better? I mean, in other words, would you welcome additional predictable sources of energy? Presumably it would reduce your balancing actions and balancing costs.
Yeah, I think in interest of time, Amrik, I can answer that question with we place huge value on the predictability of any of our energy sources. What I would say is, you know, to Tim's point, you know, we want a balanced mix of different types of generation technology on the network, because that just provides us with the opportunity to respond to any scenario that presents itself. But a huge part of the difficulty around managing the sort of second by second balancing of energy is around understanding what generators are going to do. And in a world where you have predictability, that can only be a good thing.
Excellent. Right, we have 4 minutes left. The question I posed at the beginning, Matt, let's start off with you. What one thing would you change?
Oh, what a question. Okay, so I think, and as an optimist, I think this is changing already. I just think we need to continue down this path. But it's a move to being more strategic in the way we view marine and offshore energy in our mix. I think at the moment there is still a tendency to put all of the risk on private sector developers, and we tend to react to what a developer requirement is. And so what we see is an ad hoc developments. We see delay, we see a lack of interface, and I think we all need to, or we as a society need to think about how do we move beyond that so that we can start to understand the risks far more strategically and holistically, and start to tackle it in a much more efficient way. But I think we are starting to do that, I have to say. I think we're heading in that direction. So.
Thanks for that, Matt. Chris, from you, what one thing would you like to change if you had the power?
I think if you remember on my slides, we were looking at the first stream was the sort of technical options for what we can do on site. The second site element then was about the infrastructure and supply those industry, and the third one was, of course, the base business models. So I'm hoping that those base business models, they're likely to be CFD mechanisms for industrial decarbonisation for hydrogen and CCUS. I hope they come out in a way that really attracts industry to want to go down that path. So the sooner we can start, sooner those models are out, sooner those models are attractive for industry, the sooner we can start decarbonising, and the sooner we'll start demanding more marine power.
Thank you for that, Chris. Excellent. Magnus, anything from you on the one thing that you could change, or one thing you would change?
Yeah, certainly. I'll keep it quick. Probably going to jump back on the topic of predictability. I think this is still the main criticism that renewables are faced with, and still I find myself in, when we could go to pubs and things, having to defend over. But I think we are making strides towards improving the dependability, certainly, on renewables. And as the others have touched on, by means of combining them with things like storage or hydrogen, or even powering offshore oil and gas platforms, there's a lot of work going on in that space. Nobody likes to see wind turbines not operating when the wind is blowing, and nobody likes to read about constraint payments being made to generators and things like that. I think all of these things are going to improve also by increasing diversity, not only in terms of as others have touched on, increasing the portfolio of, adding wave and tidal to the mix. That will certainly help, but also the diversity of the locations in which we have these projects. And that's, a big opportunity for the Celtic Sea. There are certainly arguments to be made about negative correlations between the east and west coasts of the UK.
Okay, thank you for that, Magnus. James, Tim, you both get off lightly, but you can email me your answers if you want. But, I think I'm going to get told off now by Manon. So Manon, I'll hand over to you. I suspect that we've run out of time. All I can say is, look, guys, thanks a lot for that. I learned a hell of a lot, and hopefully everyone who dialed in did as well. That's excellent stuff, and thanks a lot for your time as well. It's really, really good.
Okay, thank you, Amrit. Just quickly, on behalf of the Marine Energy Wales team, just like to thank you all very much to the speakers for your interesting presentations, and Amrit for chairing seamlessly as well. It's really interesting. And it was really great and encouraging to hear, Tim, that you're constantly referring back to the marine evidence consultation responses. As MEW, we did respond to all the consultations on behalf of our members, and it was great to hear that there was so much response from across the industry, and so that's encouraging to hear as well. So that's great. So thank you for joining us. Next